So what I'd like to do is just tell you a few things that you should look for in a plan set to make certain your project is going to flow smoothly. And I've got my coworkers Schwa and Will here that will help elaborate a little bit when we get to the correct section. But a good plan set includes what you see on screen: the cover page, the site plan that we'll show you in a moment, the layout, structural details, the wire diagram, all the safety labels, and the whole home placard showing equipment locations for first responders, as well as the specification sheets for all the major equipment and certification documents where necessary. And possibly, depending on the situation, you might require a structural or an electrical PE stamp. So my name's Jeff Spies. I am the president of Planet Plan Sets. We are a company that drafts permitting plan sets for solar contractors and for homeowners nationwide. We focus on generating the permitting plan set so that when you go to the building department, you aren't going to have difficulties and complexities. Essentially, we consider ourselves to help streamline the solar permitting process for our clients. I do also serve on the board of the California Solar and Storage Association, which is the industry's second largest trade organization. I'm secretary of CALSA. I do also chair the Codes and Standards Committee because I'm the biggest nerd there, I think. That said, I also serve on the board of the Industry Certification Organization known as NABCEP. I serve on a couple technical committees for UL, including the Energy Storage Standard Technical Committee, which has been very robust in the past several years. And I also helped make a documentary film about how the solar industry started. Now, solar codes and standards are complicated, and this is partly a function of the fact that it engages multiple trades, diverse set of skills, including electrical, roofing, plumbing, carpentry, and in more modern age, information technology, and trying to get all this equipment to communicate properly with one another. We've had this growing complexity of codes and standards. I call it an alphabet soup of codes and standards that consists of a bunch of 3, 4, and 5-letter acronyms, some of which you see on screen. And these codes and standards are getting more complex. I often joke that confusion is the new solar standard. Permitting and inspection is an important part of the process because essentially the federal government grants the states the rights to administer safety codes. They in turn empower your local building department to interpret and enact the local requirements for building, electrical, fire, and plumbing code. And AHJs are allowed to develop even more restrictive requirements than the code requires, as long as it can be justified based upon unique site conditions. Now, this typically must be done through a local rulemaking process called an ordinance, but we won't go into too much detail. Just realize that those authorities having jurisdiction, AHJs, make the rules. They interpret the codes based upon the state law and the state building code requirements with possible amendments that will be important when your project goes to the permitting process. Now, I want to mention that the local jurisdiction, the authority having jurisdiction, i.e. your building department, and your utility often have their own unique requirements for things like equipment locations, disconnecting means, how you would shut down the solar and or storage system when there's a safety incident going on, possibly if the house is on fire. How does the first responder know to shut things off safely? Energy storage locations has become a big issue in the past several years as the code language has evolved and as building departments are starting to think, gee, we got to put these batteries in a safe location. And we have other requirements for things like smart inverter capabilities through Rule 21 or IEEE 1547. There's a whole host of technical complexities that often enter into the picture. So what I'd like to do is step through each of these sections individually to give you a little appreciation of the information that will be found in a plan set when you're working on your solar system. The cover page is kind of a general information page showing the overall scope of work. It will, for your building department, help them quickly understand where in their jurisdiction you are located with a location on the map. It'll have some general notes that talk about things like what codes and standards would be applicable for the project. It will have the table of contents for all the different pages in the plan set, as well as important contact information. So again, good general basic information. So scope of work, you can see here, includes also the equipment that would be used. So there's a quick summary overview of that equipment, vicinity map as mentioned, general notes, table of contents, and all the contact information, which I've blurred out for this project. But this is where we get into the meat of the issue. The site plan essentially is like the map of your property, showing all critical equipment locations. Oftentimes we find that many plan sets fail to properly designate where this important equipment is going to be located. So you want to make sure that everything shown on the left side is properly detailed, including things like your septic field if you're in a rural area, or a propane tank, so that we understand where those lines are running. As an example, you shouldn't be running conduit from a ground mount PV array through your septic field.
Hey, Jeff, real quick, would you say, like, when you're working with a rural area installation, especially when we're talking grid tied, obviously, do you find that that's a lot more complex in your experience? Maybe not always, but more likely to be more complex than, say, just a suburban area where it's very, I wouldn't say the homes are cookie cutter, but they're more simplified as far as how everything's kind of hooked up?
I'll say this in a general sense. If it's a solar only rooftop, smaller array in a suburban environment, those projects tend to be pretty straightforward and less complicated. Once we get into the rural environment, where we might have a bigger PV system as a ground mount that's on a piece of property that has multiple electrical service panels scattered around the property. Maybe they have a larger electric service of 400, 600, 800 amps. Sometimes we see three-phase. Yeah, when we get to rural properties, there are a lot of variables, including higher power requirements, that can indeed complicate the development of a proper plan set.
I would like to say that in rural properties, while all that is true, it seems like the AHJs are a little more relaxed. So I think the technical design can be more complicated for your team, Jeff, but getting through permitting isn't necessarily scarier. We help those people breeze right through permits with a good plan set.
It's an interesting observation. In fact, one thing I tell people is that the building departments where we experience the most scrutiny and the most comprehensive oversight would be highly populated areas or very affluent areas. When you do get into the rural areas, jurisdictions tend to not be worried that the PV array might blow off the roof and hit some kid in the head. In a city, they worry about that stuff. But out in the country, they tend to figure, well, if the array collapses in a windstorm, it'll be the owner's financial loss. Nobody else is on the hook. I think that's changing as the industry's growing, as more and more solar is being done in the less populated rural areas. Jurisdictions are starting to ask the important question of, gosh, what should we be looking for?
Yeah, my father's a contractor, and I live in Siskiyou County, way up north, right on the Oregon border in California. And one of his biggest frustrations was just the permitting process in general, not just solar, but in general. So I wouldn't discount all rural areas to not be a little more laxed on their permitting processes, especially if you're living in California. I mean, I think it is a pain point for a lot of contractors. And I know solar's, been here the longest in California. I can see both sides, right? I guess that just depends on where you live in the rural situation.
And I just have to throw out there, and for those of you that are thinking, gee, I'll do this project and not tell the building department, or I'll not tell the utility, just be aware that there are legalities involved, including all electrical projects are supposed to, by code, be permitted. So it's not, even if you live off grid in some place like Humboldt County, legally, there is a requirement that system be permitted. And if you fail to go through that process, it could have negative implications if a fire resulted that might set fire to the neighborhood or to your local forest, or if you were to have a loss that would become an insurance consideration if the project wasn't permitted. There are indeed situations where insurance won't cover losses for systems that weren't permitted that were electrical services.
When I was speaking about the rurals being more lax, should have been more clear. If we provide them a plan set and they go to the building department that doesn't know the questions to ask, they see a very professional set of plans and they're thinking, this is cool. This has everything we need, and they're less likely to start grilling it. If you DIY with no plan set, they're more likely to pull up all the codes and throw questions at you that you're not ready to answer.
Couldn't agree more, Will. The fact is that if you approach the building department with knowledge and quality documentation, you are going to have far less problems than if you approach them with a sketch on the back of a napkin. So just to again, show you some of the details on the site plan. This is the overall property lines showing the street. And then we have the array location on the roof and all the major equipment locations. We do, as also for more involved projects, show string diagrams so that there's clarity on which modules are hooked to which other modules on the roof. And you can see some of the different strings. And then we include details that show the individual layouts with the racking rail locations, the roof attachments, which are the red dots. We'll show things like fire setbacks, pathways, junction boxes, conduit runs, all the important things that are critical for a building department to assess if the system is being installed per the safety codes. And it will also help the installer, the DIY installer or the contractor, understand where things go so that they're following the rules properly. So in this case, you'll also see where all the microinverters and module level power electronics are located with those blue squares. The red dots are the roof attachments. The gray lines are the rails and the blue outlines are PV modules. The shading on the outside is just the fire setbacks and pathways. So in addition to the layout, we will show the structural attachment detail. In this project, you'll notice the roof attachments, those small red dots, are not lined right up on the same rafter. They're what we call staggered, and that's good practice. I advise always staggering your attachments for 6 foot on center spacing, which is the norm in areas that have low snow loads and low wind loads. But when we get into high snow load areas or high wind load areas, 4 foot tends to be the norm. Staggering is always advisable. So just be conscientious that, the staggered pattern has structural benefits to your roof, to your PV array, and to getting through the building.
That's a really good tip. I didn't even realize that. And I think that kind of brings up another question. There's multiple services out there and, you got to work with what's in your budget. What would you say like a lot of homeowners need to look out for if they're working with a plan set company, as far as like there is some that you can get very cheap? What are those things to kind of look out for? Like this staggering thing, would you say that's pretty common practice, or is there some outfits out there that are just looking at it as like a quick money grab and we're going to do stuff cheap and not really do our due diligence, and here it is for like $50?
Well, typically the $50 plan set is what I often refer to as a cut and paste plan set, where they have a standard design. They apply it to every project that try to stay within that cookie cutter design mentality. And it may be correct. It may not be correct. I think the challenge is those low cost plan sets are generated by drafters who don't necessarily understand not only the codes and standards for safety, but they may not understand good design practice for long-term performance and longest life. I just feel, I've always been a believer that there's a difference between price and cost. Most people focus on initial purchase price and fail to appreciate that what they should be concerned with is the cost of that product and the cost of that design over the system life. So what we tend to feel is that while our plan sets might not be the cheapest, we feel that our customers get tremendous value because we're not only going to help keep the system safe, but we're going to assure a higher likelihood of a well-operating system that gives really good service life and maximizes the value for the customer over time.
That's a really good point. I think a lot of people look at the short-term cost of things. You see this in DIY all the time and just end up, having to pay more, not just in cost because they have to come back and buy again, but something now they'll have to actually get the better product, but also just time. Like I think we can all feel that we have, unless you're retired, a lot of people are time poor, right? We're trying to manage our time as best we can. And if we're able to get things done right the first time, measure twice, cut once, is what they usually say.
I've got a couple of bullet points on this topic. The cost of your plan set is going to be calculated into your tax credit, so you can get 30% recoup on that. When we sell a plan set, first of all, we have a system designer giving us the skeleton. Then we have me looking at that and feeding information to Jeff's team. I've got another set of eyes on it. I'm giving you a little bit better information. Then I have your team grilling that and correcting stuff that I left out and or asking me questions. Then you send us back a plan set. I send it to Schwa. So he's a fourth, maybe fifth, sixth pair of eyes, really grilling stuff. Some of the bullet points that stand out in a less professional cookie cutter plan set is voltage loss. This has been something I consider a liability when you just say, okay, this microinverter can work on number 10 wire, but they don't take into consideration that it's more than 50 feet long. 50 feet is nothing. That's like the length of most roofs. And if you have a microinverter 100 feet away and they don't calculate in voltage loss, it's not going to work. And so you have people like us doing voltage drop calculations and just making darn sure the wires are the correct size, conduits are the right size. These are little tidbits that folks don't even know. You can go online to a pipe fill calculator, figure out what size pipe you need. You might just be guessing. So all that information is real handy and definitely worth money spent.
I'll never forget my first effort to try to design a solar system. This is prior to working in the industry. And this was in the earlier days of the internet. So I was going to the internet trying to search about how to design a system for voltage drop, wire size. I was lost. And while there's a lot better and more information on the internet, unfortunately, there's way too much to differentiate between the right way to do it and the not so right way to do it, or the wrong way. And there's a lot of wrong information out there, unfortunately. Well, let's get to the wiring information. I'll just got a couple more details here that I'll mention is that, again, we talked a little bit about the staggering and the roof attachments, and we include a number of other things in the plan set. But when we talk about attachment details, we do show the structural detail drawings from the side view cutaway so that the jurisdiction can understand how those screws that are holding the roof attachment into your roof are configured. And then we are showing the individual attachments and the detailed drawings of those. The electrical plans tends to be the primary focus of the average inspector for good reason and plan checker at the building department, because it tends to be viewed as where the most critical safety considerations are. And to a certain degree, I'd agree with that. However, the wire diagram in combination with the site plan, I would say encapsulates probably about 75-80% of the critical safety information. So this wire diagram is going to be either a single line or a 3-line wire diagram. Some utilities require both. Some only require 3-line wire diagrams. It varies depending on where you're at in the country. It will address what kind of electric service you have, the meter, the service panel, the disconnects, those breakers, and how we're going to be physically interconnecting your solar output to the quote unquote point of interconnection within the electric service. So this wire diagram tends to be a pretty simple one. It's just 2 strings of PV going into a inverter that then goes into a backfed breaker in the main service panel. These can get substantially more complex, especially where bigger systems or battery systems come into play, or you've got complex electrical services that might have multiple sub panels. So don't underestimate the complexity. I don't know if Will, you might have had, or Schwa, some comments, but the wire diagrams is a point of focus for sure.
We were just talking about this yesterday. I had a customer. Can you go back to the one line or blow it up? You see how you've got those lines coming from the solar array into the system? I had a poor fellow actually pull one wire thinking that it just needed one wire. And so you bring up a good point about 1 line versus 3 line. And folks might not even know that there's such a thing as a 1 line or a 3 line, but it's important to know how to read electrical schematics, because where this shows 1 line, that's really just the path of electricity. And you have to look at the wire schedule down below to understand how many wires are in that path.
Yeah, here's the conduit schedule that Will's referencing, and it may be in various places on the page depending on your unique system configuration, because sometimes we have to find room to stick things like the conduit schedule. But the conduit schedule will call out the number and size and type of the wire, as well as the size and type of the conduit that would be applicable. Sometimes that's EMT, which is electromechanical tubing, which is a thin wall galvanized steel tube. Sometimes it'll be PVC conduit because you might be in a corrosive environment or running underground where PVC would be permissible. Sometimes the jurisdiction will overrule that and say you have to use rigid conduit, which is a very thick-walled steel conduit, which can be a lot more difficult to work with and quite expensive. So essentially, we try to make this process of knowing what wire size, what wire type, how many wires easy by incorporating that information into the conduit schedule. And there's a lot of other details that are here that once you get to this level, you'll have a better understanding of the importance of those items.
Yeah, everything is here. I've been looking at plan sets for like 15 years. And so I know what all of this stuff is. And I know that it can be really intimidating to look at. But rest assured that everything that needs to be known about your system is contained in the plan set. Like this wire diagram covers everything. The wires, how long they are, what size they are, what size conduit they go in, how big the ground is, like just with a single line. Everyone's level of understanding is so different. I feel so bad for somebody who would run only one wire and go, well, I don't know. I don't look at plan sets for a job. What do you want?
There's easy mistakes that can be made. And obviously, one of the things I really like about the way that the Gigawatt companies operates is they give a custom install guide, which is kind of step-by-step instructions. Here's what you do. This is the next step. This is the next step. And that in conjunction with the plan set and that really convenient shopping list for all the little piece parts you might need to get at Lowe's or Home Depot forms the holy trifecta of critical information a DIYer needs to be able to properly install a system and get it through the permitting process. This is the safety label and placard page. These are all the labels that are required by code that give important safety information to first responders, to inspectors, to make sure that the system is properly designed, configured, installed, and all the equipment is located in the proper location. The spec sheets also are going to be included in the plan set for the modules, inverter, rapid shutdown system if one's going to be used, racking system, and roof attachments. Certification documents would also be a component of the end of your plan set to show that the modules are certified to the UL 1703 standard, the racking systems certified to the 2703 standard, inverters to 1741, energy storage systems to 9540. So essentially, these certificates of compliance, letters of conformance will give the building department validation that these products have met the applicable safety standards required by the codes. And then you might get into some additional information, such as structural information for the particular roof, particularly for older roofs. If your house was built before the advent of modern building codes in the 1960s, many jurisdictions are going to want to see drawings of this nature and possibly get a structural or electrical PE stamp on that plan set. And then when it comes to any corrections or revisions, well, a correction is a jurisdiction saying, oh, we want you to add this to the plans or make a change here. Correction doesn't mean it was wrong per se. It may mean that that jurisdiction has some unpublished special safety requirements. Sometimes it's just adding specific notes to the wire diagram or to the site plan. So that would be a correction. And then revisions, well, it's not uncommon, and Will and Schwa can probably speak to this a little better than myself, that we see a end customer says, gosh, we don't really like how the array looks over the garage, so we'd like to move it to the other side of the house. And that would be a revision, and we certainly handle our share of those types of projects. Finally, if there is a change made during construction, we can update the plan set with what's called as built. So essentially it would be those final revisions that would replicate changes that were made on install day. My PV array on my roof was subject to a game day change of array layout. And so that is not at all an uncommon situation. Finally, the inspection will occur after the installation's done. And that's where a quality plan set really pays off. Because when that inspector comes out, if they're in possession either as a PDF or a printed out version of those plans, now they've got a really good visual of the system and how it should be put together. So just be conscientious that inspectors have an important safety validation job to do. And the more prepared you are with quality installation, quality plan set, the easier that process will be. Obviously, be respectful to these folks. They hold the power of approval in their hands. So that's basically the elements of a quality plan set. As mentioned, there's the possibility you might have to layer on a professional engineering stamp for either structural, especially if your home was an older home built before 1960, and or an electrical PE stamp, which is often required in very complex electrical services with energy storage, multiple service panels, or in any commercial projects. The electrical and structural PE stamps are standard operating procedure.
I had some questions. When you talk about roof mount versus ground mount and what that kind of looks like from a plan set perspective, what other things are you looking for on a ground mount that you might not be looking for on the roof and vice versa?
I got one. Voltage drop.
Voltage drop?
Yeah, your ground mount is always going to be 50 feet away from your service panel. And that's kind of how I benchmark when you start needing to watch voltage drop. If it's more than 50 feet, and they're usually a couple of 100 feet away, Like for instance, the first rule of thumb, don't use a microinverter as your plan A.
Well, I was going to ask, what if they're using a microinverter and they're going AC instead of DC? I mean, you're not worried about shade, so why?
Well, we try to limit those to probably no more than 100 feet of wire run from the array to the home to minimize this voltage drop concern. If it exceeds about 1.5 or 2%, what'll happen is a hot day in the summertime, it'll stop exporting to the grid all day. Now, you could fix it by buying much bigger wire, but if you haven't looked at wire prices lately, the bigger wire, copper's gotten so expensive in recent years that you want to try to minimize your wire size. So one of the things that we do is we try to come up with that great balance of the type of equipment that's used, the wire size, and there's a lot of variables that come into play when you're choosing all the different products and conductors and, gizmos and gadgets and doodads. So essentially all of those technical widgets can play a role in the final performance and safety of that system, and they have to be working in concert with one another. So as I stated before, there's thousands potentially of different variables. We are conscientious to make sure that all the different variables play nicely together.
Right. And that's just the electrical stuff. If you got into a ground mount versus a roof mount, just on the racking side of things, there's going to be huge differences. On a roof mount, we're like, do you have rafters or trusses? What size are they? How far apart are they? What kind of attachment are we going to use? A ground mount, now we're shifting gears completely to what soil type do you have? How far apart do these footings need to be? How deep do the footings need to be and how wide? If you go wider, you don't have to go as deep. If you have really rotten soil, now we have different kinds of wind loading things to consider, so it's wildly different.
And how expensive is it to get that concrete truck up to your remote property?
Dude, right? Because if you have a roof, you have an angled surface that you're mounting to already, right? And you get the little gadgets and doodads that you attach onto your already existing angled surface, right? As soon as you're going to do a ground mount, you still need all the little bits and bobs for holding the solar panels down. But now, you have all of these pipes and everything, and you're digging all these big holes to create an angled surface to mount your panels onto. So it adds a huge amount onto the cost. And in a lot of places, you have to get additional engineering for your ground mount, and you may have to do soils testing before they'll even let you dig holes.
And what if you're not on flat ground?
Oof.
Those are tricky. So side hills are the worst. When the hill slopes at the same direction as the array, that's more manageable, but you still have limitations because of the steepness of hills and whether they'd be structurally sound. So again, there's just a myriad of different considerations that have to be taken into account. Typically, a structural professional engineer is going to be engaged in reviewing those ground mounts. So I'd say a ground mount tends to add a bit of cost to the overall cost of the solar system. The beauty of a ground mount is you don't have to worry potentially about roof leaks, although I'll just mention that Gigawatt provides adequate information to make sure that the roof attachments that would be matched to your particular roof type, when installed properly with the instructions they provide, can offer long-term reliable waterproofing performance.
Part of my job, anytime we sell a system, it goes to me to create the racking engineering. We use a company called Iron Ridge, and they have really cool engineering tools on their website. And if you know how to use the tools fluently, like I do, because I've been doing them for 15 years, you can breeze right through it. I share these with my customers sometimes, and they're just like, what? I don't understand any of this. Well, I do that for you for free. That's just something I do every day. And we do the roof racking. It's like you're saying, Jeff, we look at the site. We're specific for your house. If your array is out in the field, I'll do a ground racking engineering and then consult with you on it. Like, how deep can you actually dig? Because there's different ground racks. There's 2-inch or 3-inch. They have deeper holes. For instance, if you use 3-inch pipe, they have long span capabilities. So you have less piers and less holes, but they're like 7.5 feet deep. So on the flip side, if you switch to 2-inch pipe, it's cheaper and shallower holes, but now you've got like 3 times as many piers. And so those are conversations that we have with each customer to specifically design this.
It's not anything you just want to force on somebody. Somebody wants a ground mount, and then you just dream up whatever is convenient and say, this is what you're to install, right? Without them having any knowledge or input on any of the variables. We're just being like, yeah, this is probably good.
I think the conversations I've had with a lot of people is like they instinctively want to do a ground mount. They don't really take in consideration all the additional costs. I'm always an advocate for like, if you could do a roof mount and it's not the perfect angle, throw a couple extra panels on there. It's going to be way more cost effective, less of a headache, and you're going to be just as happy. Your roof's going to be completely fine. And you're going to get the best return on investment doing that.
But we know ground mounts. So if you're bound and determined to do a ground mount, come our way because we can really help simplify the process.
This question is probably for all three, but I'm thinking because Schwab brought it up, you guys are dealing with a lot of customer support. What are, would you say, the top one or two or maybe three things that you see common where people get these plan sets and they do make a mistake because they just were not aware of something that, man, if they just had a little bit of notification on that, they would have been more conscious of that while they were doing it, and they might have been able to overcome that. Like you said, like the one line thinking it was just one wire. Is there anything, other examples that are more common that you guys see happening that, you know, these people can look out for?
People just don't include enough detail. They want to give you, here's the pictures and a couple of things, but we're, you know, going, well, that's awesome. We really appreciate the good information. We also need to know if you have natural gas or propane and where it is and where it's buried. And it's rare for somebody to include all of the things that are needed in one go, just because there's so much. Yesterday, I was talking to a guy who is putting together a ground mount, and it is known to be in a floodplain. And so the historical flood level needs to be addressed with respect to the level of his ground mount. And so it's turned into, I need you to procure the IP68 rating for this panel. This only says the junction box is IP68, and my inspector requires an IP68 for the entire panel and not just the junction box.
And we've seen projects canceled for that reason, where the array's in a floodplain and the local building department says, you've got to make sure that this array is not going to go underwater. So that building department was cool with it going underwater as long as the modules can operate underwater.
And I was thinking, this is one of the weirder things that somebody has asked me for with regard to their plan set. I need you to include something that says these panels are rated to function underwater.
Just for clarity, we are not endorsing underwater solar systems.
No.
Well, that brings up another good question or a thing too, because a lot of people are like, well, what if I get all this stuff and then it doesn't pass, right? And I think that's what's really great about Gigawatt and Go Green and Unbound and the companies alike is that, well, if you could get a plan set through us, we actually have a guarantee. Like if you can't get the plan set approved, you get a full refund on everything.
I'll just add that in the vast majority of these cases, because of the technical expertise of the staff with the group of Gigawatt companies, we have the capacity of working with the jurisdictions to answer their questions and come to a acceptable solution that will allow these projects to go forward. Just today, for a project up in Wyoming I was working on, the jurisdiction was asking a question about a maximum current rating that's intended for sizing only the wires, and they were applying that limitation to an inverter, which was inapplicable. So we had to get a letter from the manufacturer of the inverter saying that code section doesn't apply to the input of our inverter. It applies only to the wire, so that there was clarity that we were in compliance. So we do find, unfortunately, a lot of jurisdictions understandably don't understand the technology yet. And so they may not even understand how to apply the code. And we get corrections that may be based upon a misunderstanding of the code language. So we live and eat and breathe the codes and the standards. So we're well qualified to have that informed discussion with the building department and act as a advocate on your behalf to make sure these projects get put through the system okay.
That's really cool that you're actually changing policies as you go through and in like working with the customer to do that. Because I think if a customer tried to do that on their own, even if they were kind of well versed, it would probably be more difficult without having the expertise that you provide. So that's really cool that you're changing policies as you kind of go.